This is going to be a really short video because the first section of this we're actually going to talk about in class. The whole first page of this on transforming data we are going to do as a activity in class on Wednesday or Thursday, depending on what period you have statistics. So this whole first page, including the example at the bottom, and the check your understanding, we will work through actually in class because it's a good example that we use to explain it, and it can be better talked about in class than on a density curve. Okay. A density curve basically is a trace of your graph. Whether that be that it is a trace of a histogram or a dot plot, basically you are tracing over your graph to see what your graph would look like. And you can see these little red curves here. Those are density curves that are tracing these two graphs. Okay, we use a density curve to describe the overall pattern of the distribution. So maybe I don't have exactly every data point, or I don't know exactly what every data point is, but in general I know that the general shape. So I can use a density curve to describe that general shape. So I know if it's skewed left, I need to draw a density curve that looks like this. I know if it's approximately symmetric, I need to draw a density curve that looks like this.
Traits of a density curve that we always need to remember are: one, they always must be on or above the horizontal axis. So basically they can never be negative, they can never go down, and basically they just have to be on top of a number line. Okay, number two, and this is always true no matter what shape the curve takes, the area under the curve must be equal to 1. Because what a density curve can measure is it measures basically your frequencies or your relative frequencies. So when I add up all of these relative frequencies, they must all equal 1. So let's talk about how we describe density curves. The way to identify the mean and the median of a density curve is to look for very specific points. The mean is what we call the balance point. And we talked about this a little bit in the last chapter, but I'm looking for, if I wanted to balance the density curve on one point like a seesaw, where would that point need to be? Okay, the median is the halfway point. I want half the area on one side of the median and half the area on the other. In calculus, you can find the median using calculus because a density curve actually never touches the x-axis, so its boundary points are negative infinity. That really doesn't look like an infinity symbol. Negative infinity on one side and positive infinity on the other, and I know that the median is the middle point. So if I know the equation for my density curve, we call that f of x, I can find out what m is by integrating from negative infinity to m, and I know that that area must equal the area, and I forgot my dx here, sorry calculus people, from the median to infinity of f of x dx, because I know that half of my area, which is the integral of the curve, is on each side of the median. So you don't have to do that for statistics, but if you're taking calculus, just another way to look at it. Okay, we always need to use Greek letters to represent the mean and the standard deviation, which means in a density curve, my mean is mu, my standard deviation is sigma, because these are an idealized description. I'm not actually dealing with any data points. I'm saying ideally, this is what this data set would look like. So we treat it kind of like a population, and I use the symbols for population. So it's an idealized description. Okay. The most common type of density curve, and we will start talking about this tomorrow, is the normal distribution. I'm sure you talked about it some in Algebra 2. Sometimes it's also known as the bell curve, but it is the most common type. of density curve, and it's very special to us in statistics. So this will be the focus of most everything for the rest of the school year is the normal distribution. Okay, so last thing we're going to do is these check for understanding questions. So take a second, pause the video, do these check for understanding questions. Number 1, it should be positive everywhere, and it has an area equal to 1. Number 2, about 12%. So for number 3, if we look at the shape of the density curve, it looks kind of like this. This right here would be A, which is the median. It's my halfway point. And I know that in skewed distributions, my mean gets pulled towards the skewed. Okay, and this would be my balance point, so it would be as my mean. So that would be somewhere in those vicinities. And number 4, you need to say that the mean is less than the median because it is skewed left. And you should always write all of your answers in complete sentences.